Hello guys. In the previous video, we learned how to position a line relative to a circle. So there are three possibilities when it comes to a circle and a line. A line can completely lie outside the circle, right? Outside the premises of the circle. Or line can be a tangent to the circle. That means the line and circle touch at just one point. The third possibility being line can cut the circle, right? So those are the three possibilities. Now let's learn how to find the equation of the tangent to a circle at a point. That is the second possibility. The line can be the tangent to a circle, right? So how do you find the equation of the tangent line to a circle at a particular point on the circle, right? So we're going to learn that now. Here's a sketch on this. We have a circle which is given with this equation, right? X squared plus y squared plus 2gx plus 2fy plus constant equals 0. This is the equation of a circle. Now suppose you have a tangent line, right? And you know the point at which the tangent occurs, right? So point at which this tangent line touches the circle. This point is known. Right? So given this circle, equation of the circle, you know how to find the center of the circle. So you put negative sign, then 2g divided by 2, that is just g. Negative sign, 2f divided by 2, that gives you just minus f. Okay, so this is the coordinate of the center of the circle. Now here's what we are going to do. Now we need to find the equation of a line. So to find the equation of a line, you can find it if we know 2 points on the line, right? Or if we know the gradient and the intercept of the line, or if we know the gradient and just 1 point. There are other ways to get this done. Suppose you know the y-intercept and x-intercept, that then also you can find the equation of the line. But here you can see that 1 point is given. This point is given at which the tangent is drawn on the circle, to the circle. And if you know the gradient of this line, then you can find the equation of the line. This is what we are going to use here. Now see that this point is given, obviously the center of the circle is known if this is given. So we can find the gradient of this line. We can find the gradient of this line. So gradient MPC line should be y0 minus y coordinate, then x0 minus x coordinate. Right. This will be y0 plus f over x0 plus g. This is the gradient. Now you know that if this is a tangent, it would be perpendicular to PC. So since line L equals 0, I'm just going to give it a name, L equals 0, is perpendicular to PC, gradient MPC must be, gradient of the line must be equal to minus 1 over gradient of the line PC. This is a well-known fact. So what does that tell you? You take the reciprocal and put a negative sign. So x0 g y0 plus r. Now you know the gradient of the line as well. So the gradient is known. A point, the point at which the tangent is drawn to the circle is known. So we can write down the equation right away. Therefore, equation y minus this y0 equal the gradient. This is minus x0 plus g divided by y0 plus f, x minus x0, y minus y0, gradient times x minus x0. Good. Now we'll solve this equation here. So if I cross multiply this, y minus y0, y0 plus f equals minus times the product of this. So I'm going to bring it to the left hand side, then it becomes plus x0 plus g, x minus x0 equals 0. Right. Then I'm going to simplify this bracket. So y into y0 plus y into f minus y0 squared minus y0 f. Then these two brackets, x0 x minus x0 squared plus gx minus gx0 equals 0. Right. Okay, so if this is a numerical problem, you would obtain the equation right away. Okay, so if it is a numerical problem, you get a value for this. Then it's easy, just line. Now here's the thing. We are going to relate this equation with the equation of the circle and you will see a beautiful relationship. Okay. So for that, what I'm going to do here is that since P x naught y naught on the circle, right? Since P x naught y naught is on S equals 0, this point must satisfy this, right? So x naught squared plus y naught squared, then plus 2gx naught plus 2f, y is replaced by y naught, plus c equals 0. Using this relationship, now here we have minus y squared naught, sorry, y naught squared, then minus x naught squared. We are going to replace these two in terms of these terms using this. Okay. So what I'm going to do here is that then if I bring both of these terms to the other side, then I would have 2gx naught plus 2fy naught plus c equal minus x naught squared minus y naught squared. Okay. So we have minus y naught squared, then minus x naught squared. These two can be replaced by this. Okay. So this implies y naught plus yf. Instead of these two, we can write 2gx naught plus 2fy naught plus c. Then the remaining terms minus y naught f plus x naught x plus gx minus gx naught equals 0. Right. So let's look at the terms that will be cancelled out. We have 2gx naught. We have minus gx naught, that gives me just gx naught, and also 2fy naught. We have minus y naught f, so that gives me just y naught f, just one of them. And we have y naught x naught, so I'm just going to write that x naught plus y naught. Then we have gx naught and x naught. So gx naught and gx, because one of these two, the one gx naught will be cancelled out, so we have gx naught remaining and we have gx. So I'm going to factor out g and write x naught plus x. Then similarly f times y naught plus y plus c equals 0. This is the relationship. Okay. Now I'm going to erase everything here and I'm going to write this down here just to compare. Right. So you don't need to memorize this relationship. No need to memorize anything. Just study the way I went through these steps. Why I did that. So we used a basic relationship, that is, this line is perpendicular to this PC. We already know a point, right? Then we have to calculate the gradient. Once the gradient is obtained, we can find the equation of the line. Now I went through a few more steps just to show you a beautiful relationship, a beautiful connection between this line and this equation of the circle. Because without going through any of these steps, if you know how to get this right away, then you can write down the equation of the tangent. Here, look at this: x naught, y naught, g times x plus x naught, f times y plus y naught, c. We have x here, we have y here, and we have coefficients for both. And also, right? So when you simplify it, you will get x terms and y terms, then plus a constant. Here's what I'm going to do. Let me show you how to obtain this relationship right away. So we have x squared. So I'm going to write x instead of x squared. Then plus, instead of y squared, I'm going to write y into y. Then we have g times 2x. So I'm going to write g 2x. So x plus x. Nothing changes here. Right? It's the same equation. Then I'm going to write f. Since we have two y's, so I'm going to write y plus c equals 0. What I'm going to do is that I'm going to change one of these x's in each term, one of these x's into x naught and one of these y's into y naught. Right? Only one. So I'm going to pick just this x. Right? I'm going to write this. I'm going to replace x by x naught, this point. Then I'm going to write y and replace this by y naught, g. So one of these x, I'm going to leave x here and replace x naught. f y plus y naught plus c equals 0. See how we obtain this relationship? It's the same thing. It's the same thing, right? So if you can remember, if you can memorize this relationship, okay, how we have obtained this from the equation of the circle, then you can directly write down the equation of the tangent to a circle at a certain point. Or you can just go through the procedure. That's up to you. So let's look at an example. Right, so look at this example. Find the equation of the tangent to a circle, this circle, at 2, 1. So let's sketch this. This is s equals 0 and you have this point 2, 1 and to a line, a tangent. Then right away you have to find the center coordinates. So you put minus sign, 2 divided by 2, that is 1. Then put minus sign, minus 6 divided by 2, that gives you minus 3, minus 3 into minus, that gives you plus 3. Right? Minus 1, 3. This is the center. Now here's the thing. So 2, 1 here. This is perpendicular, so method 1. Right. Since this is a numerical problem, then we can reuse this method. So first find the gradient. Let's call this point P. MPC. Gradient would be 1 minus 3 divided by 2 minus 1. This is minus 2 divided by plus 3. 2 divided by plus 3. Therefore, gradient of, let's call this L equals 0. Gradient of L must be minus 1 over MPC. So this is the reciprocal and with a sign change. Okay. Therefore, equation of the line y minus y naught in 3 by 2 x minus x naught. X naught in this case is 2. Okay. So I can multiply this whole thing by 2. 2y minus 2. Then 3x minus 6. So 2y minus 3x plus 4 equals 0 is the required equation. Okay. So let's see how we can use this equation to get the same equation. Okay. Method 2. So instead of x squared, I'm going to write x and the point 2 plus I'm going to write y and the y point into 1 plus I'm going to write, this is 2x now, just g should be 1 in that case, 1, x plus x, so x plus 2, then I'm going to write g, let me call g should be, f should be minus 3, y plus y, so y plus y naught should be 1 minus 3 equals 0. So we have 2x and x, that gives me 3x. Okay, 3x. Then y minus 3y, that means minus 2y. Then we have plus 2 minus 3 minus 3. So minus 4 minus 6 plus 2 minus 4 equals 0. Then I'm going to multiply this whole equation by negative sign, then that gives me 2y minus 3x plus 4 equals 0. The same equation. Okay, so you can use either method, that's fine. If you can't memorize this one, use the procedure, the given procedure, then it's totally fine. Okay, thank you.